Hello and welcome to a tutorial on polynomial functions. Okay, now first thing we're going to talk about, what the heck is a polynomial? All right, so first thing I want to talk about, what is a monomial? All right, now monomial itself is what we're going to know about the monomial is it's a real number, it's a variable, or the product of a real number and one or more variables with the whole number exponents. Basically, if I write down this 3x squared, that is a monomial. Okay? Now, the degree of the monomial in one variable is the exponent of that variable. So in this one, this particular one, I'm going to go ahead and say that the degree equals 2, because the 2 is the highest power that I see. All right? Now, a polynomial is a monomial or a sum of monomials. The degree of a polynomial is one with the greatest degree. So if I was to talk about what is a polynomial, that could be this kind of thing: 3x to the third plus 2x squared plus 3x minus 4. That would be a polynomial. Basically, it's consisting of 4 monomials. All right? So when we talk about a polynomial, we know that's a sum of monomials. The degree of this particular one is the highest individual power, and I see that the highest power on this one is 3, so that would be degree 3. All right? Now I went ahead and wrote this in standard form. Now just like with a quadratic, standard form of a quadratic function starts with something like y equals 3x squared plus 4x minus 5. Okay, that's considered standard form. There's no parentheses and things are in descending order. The same thing with the polynomial function. Officially, it ranges the term by degree in descending numerical order. And I have a couple examples for you from the book. They use a different terminology here, but they'll be talking about a sub n means that would be a coefficient. And they're just showing different coefficients on here. All right, they're describing them. Now here's a quick little breakdown of some of this stuff. Okay, a cubic term is to the third power. Quadratic term is to the second power. You see that in blue. Linear term is to the first power. The constant term is all right. X to the third, x squared, x to the 1 power. And a constant term actually can be translated to x to the 0 power. Now 0 power is the same thing as the number 1 in all cases. Next, we're going to talk about classifying polynomials. So we want to rewrite it in standard form and then find the classification by degree and number of terms. So for this first one, it's going to get rewritten with the 9 first. And then 3 comes second, and the 5 comes last. It has degree 2 and 3 terms. 3 terms is called a trinomial. On the other one, you're going to start with the x to the 4th term. And the next one, there's no x to the 3rd term, so we skip it. X squared, I'm going to go ahead and combine -6 and +10. So I get positive 4x. And the 4x is next, and the 12. That has 4 terms. They're using the term quartic. All right. All right, so to rewrite this one, I went ahead and said 5x to the 4th comes first. Next is 3x cubed minus x. So it's got the highest degree is this 4th power. So it's called degree 4. It's a trinomial, 3 terms. This next one, negative 4x to the 5th is the first. 2x squared comes second. I can combine 3 plus 10 to get 13. This degree is 5, and that's a trinomial. Next, we're going to talk about what's called turning points. Places where the graph changes direction. Very important. It also affects the end behavior. the directions of the graph to the far left and far right. Okay. When I first look at this quartic function that has degree equals 4, okay? Now you can see that this starts from up and it ends with up. You can tell that by the equation. So that's what's called end behavior. How do the ends look? So we'll then be able to see that if it's a fourth degree is up and up. Okay? Now notice second degree over here. If we look down at that one, that was down and down because it started with a negative. So I have fourth power here, but it was a positive 4, x to the fourth, and then the other one was negative 1 right here. So basically, if it's an even function, it's going to look like this. I want you to think about a parabola. Okay? If it is a parabola, if it's even, it goes up and up. So it's going to be this kind of style. If it's negative and even, just like a parabola, it'll be down and down. Okay? So the other thing on here, where does it turn? Now we'll just use the calculator to help us with this particular one. So the 3 different turning points this has. Okay? Negative 1.07, negative 1.04, negative 0.27, and 0.17. Okay? And we're back. Okay, we were talking about what we set up with. We have the even behavior. The even has either up and up if it's positive, and down if it's negative. So if I had this y equals negative x to the 6th power plus 7. The only thing I'm worrying about is the leading number, okay, which is right here. I know that's negative, so regardless of the turning points on this, it is going to be, it's negative even, so it's going to be down and down. Now let's talk about the odd groups. Now over here is an example of what's called a cubic function. This is the y equals x cubed function. Now it's got an unusual look to it. If I did a little table, it would look like this. 0 times 0 times 0 is 0. 1 to the 3rd power is 1. 2 to the 3rd power is 8. Now if I go negative, negative 1 to the 3rd power is going to be negative 1 times negative 1 times negative 1, so it's negative 1. Negative 2 gives you negative 8. So what happens in this group, uh-oh.
Mike Pierce, please call the operator. Mike Pierce, please call the operator.
So now what I've got is I have, if it's just x cubed, I know I've got my a value, my first is going to be positive. My n, which is what is the exponent, is going to be odd. So in this case, I see that it starts as being down and up. Okay? So we see that. That tells us that we have, if that x to the 3rd power was positive, we're going to have down and up. Now let's go over here. If I have negative x to the 3rd power, okay, now the negative in front of that is going to mean it starts in the up direction. Now, we have some turning points here. We'll get to what that means eventually. But our main focus now is if I think about linear equations. Let's say if I have y equals negative 2x plus 1. That would graph going through -1. So I'd start at -2, so down 2 over 1. So that's going to look like that. So that is an up and a down. Okay? And then, if conversely, if I decided I was going to do y equals 3x minus 2, that one would be down and up. So our rules on this are as follows. If we have odd behavior, if the first number is positive and the exponent is odd, it's going to be down and up. Conversely, if the first number is negative and the exponent is odd, it's going to be up and down. Let's see if we can explain a little bit further in the next slide. Let's look at these two. When I have 4x cubed minus 3x, I know that's going to be positive and odd. That's going to react exactly the same as it would have been if it was a line. So that's going to look approximately like that. And that's going to be down and up. Now over here, I'm just going to focus right here. So what I have on this one is negative and even. Now the evens have the same. If it was a parabola, it would have been like that. That's down and down. And I'm looking at this one here. I have negative 4x cubed. So we have even and we have the value being negative. So I'm sorry, the n is not even in this case because it's 4 to the third power. The n is odd. So our behavior is opposite. Okay, so if it's negative, what's going to happen? It's going to be up and down. Now to see how some of these might graph, we can open up our graphing calculator to peek at a couple examples. Let's go ahead and put that same equation we just looked at in there. All right, y equals negative 4x cubed. And just remind you, the way you do the cube is using the caret button, which is right above the divide sign. And I'll say plus 2x to the power of 2 plus 7. I'll make sure my window is under zoom 6 for now. I just want to see what the general behavior this looks like. Okay, so it looks like it starts on the up and it goes in the down. If I zoom out a little bit, or maybe I'll just change my window slightly, so I have -5 to +5 on the x values, and I'm going to just increase my maximum y to 20. I can get a little better view of how this cubic function looks. So there we go, down and, up and down. So this is pointing up, and this other one's pointing down. So here's another way of graphing the cubic functions. We aren't going to get too crazy with it right now. We're going to just use the calculator to help us to start with this. I mostly want to focus on how it's going to look. If I take this same idea right here, negative x squared, I know it's going to be odd, so I have opposite behavior, and it's negative. So odd, negative. If it was a line, it would look like this. So I know that's going to be up and down. The same thing with this one. This, part B, I have positive x cubed. It was a line, it would have looked like this. And that would be odd and positive. So that's down and up. All right. As far as graphing this, we'll hold off on graphing for now. Now these are a couple things we're going to do for our assignment. Okay, we're going to rewrite things in standard form and classify it by degree. I'll pick out one random one on here. Let's say I go to number 19. I'll rewrite that in descending order. The highest power I see here is the x to the fourth, and it's negative. So negative x to the fourth. Now I have x second, x squared plus 2x squared. So I'm going to say plus 3x squared. The degree would be 4. Okay, the number of terms are 2, so it's called binomial. All right, let's look at end behavior. I'm going to go to this number 23. Now that degree, n, equals 11, and that is an odd number. The a, which is the leading coefficient, is 8, and that is a positive number. So odd numbers, remember, have opposite behaviors. If it's positive and odd, it will be up. I'm sorry, I have to kind of think of a line. A positive line looks like this, so it's going to be down and up. Okay? All right, that's all for now. Stay tuned for the quiz.